Okay, so now we're going to try to transpose this next equation. Ax is equal to bx plus cy plus d. Now we're going to try to solve for x, but this time we have x on both sides of the equation, both on the right and the left. So it's not quite so simple as it was last time. So here's another tool that we can use, and that is to combine all of our x terms, to bring all of our x terms together. Bring our x terms together. So to bring these x terms together, I need to get this x term over to the other side of the equation. And I'm going to do that all once again by respecting the bed mass process, but working opposite through it to move things from one side of the equation to the other. So I have addition and subtraction. I've got my addition over here. So to move this x terms, I have to treat it like a full term and move the entire unit over. So I'm going to subtract bx from both sides of the equation. So I have ax minus bx on one side is equal to bx plus cy plus d minus bx on the other side. Made sure that I subtracted on both sides. So this way I have ax minus bx is equal to, and these two bx terms cancel each other out now. So I get cy plus d. Now I want to have x isolated. So what I'm going to do is I'm going to try to put it as a singular term on one side, or factor it out. So that's going to be our next tool, is to factor x out. So I have x times a minus b. We learned this in our previous factoring videos, is equal to cy plus d. Now I'm still going to be doing the opposite of bed mass so that I can isolate that x term. Now what would be happening is brackets would be coming last. X is being multiplied by this combined a minus bx term. And I want to move that whole term over by dividing, because it's being multiplied. I'm going to divide by a minus b in brackets, still respecting those brackets because that would be the last thing to work through. So I have x times a minus b divided by a minus b is equal to cy plus d divided by a minus b. So this a minus b and this a minus b cancel each other out, and I'm left with x is equal to cy plus d over a minus b. And I can ignore the brackets because a numerator is implied brackets and a denominator has implied brackets. Okay, let's try another example.